Hi everyone, back for another lesson of quadratics in quarantine. Okay, as promised, the last couple days I mentioned that we're going to move into factoring. So I just want to discuss what factoring is. I think if we have a good understanding of what factoring is, it's going to help us do it. So first of all, when we talk about factors, if I gave you the number 12, when I'm talking about factors, I'm talking about numbers that when multiplied with each other give us 12. So for 12, our factors 1 and 12 are factors because 1 times 12 equals 12. We know that 2 and 6 are factors because 2 times 6 equals 12. And 3 and 4 are factors. So these are all factors of 12. And up here I've written down already greatest common factor. So sometimes with two numbers, so if I give you 24, the factors of 24, well, we know 1 and 24 are factors, because 1 times 24 is 24. 2 and 12, 3 and 8, and 4 and 6. So these are all factors of 24, these are all factors of 12, and the greatest common factor is the greatest factor that they both have in common. In this case, it's 12. And so we're going to be using factors and greatest common factor to do factoring. Now, factoring is sort of the opposite of what we've been doing so far. So we've been doing questions like 3x plus 2 times 2x plus 4, and we've been foiling these out. So 3x times 2x is 6x squared, 3x times 4 is plus 12x's, plus 4x's, plus 8. And when we simplify this, we get something like this. So we've been going from here to here over the last week. Factoring is doing the opposite. Factoring is if I say, what times what equals 12, you can give me factors. We're going to do the same thing. I'm going to ask you, what times what will give us this? And the answer is that. 3x plus 2 times 2x plus 4 gives us this trinomial. So these are the factors of this. So in elementary school, we stuck to constants, just numbers to come up with factors. Now we're going to break these down. So we're going to be going the opposite way. So anytime over the next week or so when you hear factoring, it means taking this and saying, what times what will equal that? That's factoring. Now, I think you understand this up here. So let's do a couple more examples. What about if I gave you 2x and 2y? What's the greatest common factor here? Well, my factors here are 2 times x, and my factors here are 2 and y, because it's 2 times y. So the only thing that these have in common is this. But remember, x and y are factors. If I was to give you 4xy, and if I said what times what would equal this, you might say 2x times 2y. So 2 times 2 is 4. X times y is xy, or x times y. So this is the factoring that we're going to be doing. I'm going to be giving you monomials, binomials, trinomials, polynomials, and we're going to be figuring out what times what equals those. Now, there's a multitude of different ways of factoring. Each day I'm going to go over a different one with you, and then you can apply them. And at the end of this unit, those of you who are good at factoring are going to be the ones who recognize the polynomial that you're dealing with, and you know which of the factoring methods to apply when. So a little bit of practice, that'll come naturally. Just as a bit of a recall from last day, there was a couple special instances, and if you recognize those, then factoring becomes very easy. So last day we talked about this. And I don't know if I mentioned or not, but this is called a perfect square trinomial. And we know that when we FOIL this out, because it's a plus b times a plus b, we get square the first, square the second term, multiply these together, a and b, and double it, so we get 2ab. And we had another one here that looked like this. Likewise, and our middle term is minus 2ab. And I also introduced you to difference of squares. And that's where we have a minus b, a plus b. It's a difference because we have different signs here. And this is the resulting. If you can recognize this, and this, and this as these as perfect square trinomials, and this is difference of squares, coming up with the factors is very easy. So this times this will give us that. So these are the factors in a difference of square. And a minus b times a minus b, that's the factor of this. So let's try a few of these. So if I give you 2x squared and 4x, here, let's just find the greatest common factor. Let's practice finding the greatest common factor. So in this case, we have 2 times x times x. That's basically what gives us this. These are our factors. 2 and x are the factors of 2x squared. And here we have, I guess, 1 times 4 and 2 times 2. So, and I guess I could have put a 1 here as well. So 1, 2, 4, and x. These are all our factors here because 1 times 4 is 4, 2 times 2 is 4, and x is a factor. So what's our greatest common factor here? Well, in this case, it's 2x. So our greatest common factor here is 2x. 6x squared y and 9xy. So our greatest common factor here. So what we're looking at is we're looking at a greatest common factor of the coefficients and then of the variables. So for the 6 and the 9, we have 1 times 6 and 2 times 3. For the 9, we have 1 times 9 and 3 times 3. So our greatest common factor of the coefficients is 3. And for the 6xy, we have an x, and a y. Here we have an x and a y. What do we have in common? We have xy in common. So our greatest common factor is 3xy. And let's do another one here. 21c4d3, 28c2 d5, and 7 c1 d3. So looking at the coefficients, for 7 we have 1 times 7. For 28 we have 1 times 28, 2 times 14, 4 times 7, and I think that's it. And for 21, we have 1 and 21, and 3 and 7. So our greatest common factor here among the coefficients is 7. And for our variables, C4, C2, C1. The greatest common factor among those is C1. And for D3, D5, and D3, D3 is the greatest one that's in common. They all have 3 Ds. All right, so moving on with that. So factoring is, as I mentioned, going backwards. So if I gave you a question like 3a squared b times 4a plus 5b, a couple days ago we would have foiled, or not foiled this out, but we would have multiplied this out. And please recognize that we have 2 terms here. This is a binomial. So it's 3a squared b times this, and it's 3a squared times this. So when we do that, 3 times 4 is 12. A squared times A1 is A3, keeping the base at an exponent. And B times nothing just stays as a B. And then our second term, 3 times 5 is plus 15. A squared times, there's no way there, so it just stays as an A squared. And B times B, keep the base, add the exponents. So that's expanding. Well, if I gave you this and said, what are the factors? You're going to be able to say, that's one factor, and that's the other factor, because that times that will equal that. So it's going in reverse. All right, so let's practice some of these. And so the way that we're going to go from here to here is we are going to factor. I don't know if you notice, but 3a squared b is actually the greatest common factor of this. So between 12 and 15, my greatest common factor there is 3. Between A3 and A2, I got 2 A's in common. And B and B2, I have 1 B in common. That's my greatest common factor. So what we're going to do is, 1, we are going to find the greatest common factor. 2, we are going to pull it out by dividing the polynomial by it. So once I get 3a squared b, if I took this and divided it by my greatest common factor, I will get this. And that's how we get our two factors. So if you're a little bit confused, let's go through a few questions right now and hopefully it'll clarify it. So 4n plus 10. So we have two terms here. And basically I want to know what times what will give us this. What are the factors of this? So my greatest common factor, and you don't have to write this out every time. I'm just doing it for illustrative purposes. If you can see the greatest common factor here, which a lot of you are going to be able to, then that's fine. So for 4n, we have 1 times 4 and 2 times 2. And we also have times n. And for 10, we have 1 times 10 and 2 times 5. Our greatest common factor is 2. So our GCF equals 2. So what I'm going to do is I'm going to divide this whole thing by 2. And when I do that, remember you divide each of these terms by 2, so 4n. And so I'm going to put the greatest common factor out front. So there's my GCF. And let's divide this up by 2. So 4n divided by 2 is 2n's. And 10 divided by 2 is plus 5. So remember, we're dividing this up by 2, and then we're dividing this up by 2. There we go, this is factored. That's one factor, and that's the other factor. 2 times 2n plus 5 will give us this. So carrying on with the mathematical funness, what do we have in common? So our GCF here, the greatest factor that we have in common between 21 and 14 is 7. So remember, 1 times 21 and 3 times 7. And for 14, we have 1 and 14 and 2 and 7. So that's for 14. So you can see that 7 is the greatest. Once again, you don't have to do this, but do write down the GCF. And for the letters, we have 2 A's here and 1 A here, so we have 1 A in common, and we do not have B in common, so this is our GCF. So let's write it down, and let's find out what we multiply it by to get this. So let's divide this up by our greatest common factor. 21a squared divided by 7a squared. 21 divided by 7 is 3. A squared divided by a is a. Remember, keep the base, subtract the exponents. And minus 14 divided by 7 is minus 2. A divided by a is gone. And we're left with a b. There we go. This is factored. This times this gives us this. 7a and 3a minus 2 are our two factors. And we'll do another one here. Let's do a trinomial this time. All right, so we have 3 terms this time, and we have to find our greatest common factor. So our greatest common factor of 4, 6, and 8 is 2. And as far as the variables, we have 3x's, 2x's, and 2x's. So x squared is our greatest common factor there. And no y, and y, so y is not in common. So that's our greatest common factor. So what do we have to multiply it by to get this? So let's divide this up by 2x squared. 8 divided by 2 is 4. x3 divided by x2 is x. Our middle term, negative 6 divided by 2 is negative 3. X squared divided by x squared. Keep the base, subtract, we get x0, which is equal to 1, so x is gone. And we have a y squared here. And our last term, 4 divided by 2 is 2. X squared divided by x squared, it's gone, it's just 1. We don't have to write in a times 1, and we're left with a y. So there we go, factored. We've taken this trinomial and we factored it out. We know that this times this equals that. All right, let's do a couple more examples, then we're going to move on to one other way of factoring. So 6a squared minus 5ab plus 11b squared. What's our GCF? Well, for our numbers 6, 5, and 11, we don't have one. 6, of course, is 1 times 6 and 2 times 3. 5 is just 1 times 5, and 11 is another prime. It's just 1 times 11. Nothing in common there except for 1. And we're not going to, if we divide anything by 1, we just get the same answer. So we have no common factor other than 1. We're not concerned about 1. And for the letters, for this here we have a times a, or an a squared. Here we have an a and a b. And here we have a b squared. We don't have anything in common. So this here, we just say, cannot be factored. Sometimes there's nothing times nothing will equal this. It's unfactorable. All right. Now another little look here. Let's do w plus 1 plus 5y w plus 1. All right, we have 2 terms here. We have this, and we have this. And remember, terms are separated by an addition sign or subtraction sign. So this might look like 2 different things, but it's not, because we know that this can be simplified. Now, in order to factor this out, we don't have to expand this and do this distributive property. In this case, w plus 1 and w plus 1 is common to both these terms. So in this case, I'm going to write it up here, our GCF is w plus 1. And if we pull that, so w plus 1 is one of our factors. It's our GCF. And if we divide this all up by w plus 1, when we divide this term up by w plus 1, they sort of cancel each other out, and we're left with a 4x. And here, when we divide this term up by w plus 1, they cancel each other out, and we're left with a 5y. So w plus 1 is one factor. 4x plus 5 is the other factor. This times this will give us our initial statement. So let's practice a few more of these. All right, so hopefully you can see right off the bat here, our GCF is y minus 4. It's what both have in common. Outside the brackets, there's nothing in common between 2x and minus 3. Same thing up here. we had these in common. There was nothing in common between 4x and 5y. So this is our GCF. So it's our first factor. If we divide this up, for our first term, and we're not really canceling out here. So y minus 4 over y minus 4, anything over anything with the same numerator and denominator just equals 1. So what we end up with is 2x times 1, which is just 2x. The short form or the shortcut is we just say they cancel each other out. And likewise here, when we divide up this term, these two just become 1 or cancel each other out, and we're left with the minus 3. There we go, factored. And one more and then we'll move on. So let's x minus 3 minus 2x, x minus 3. All right, our greatest common factor here. We're just going to pull this out of both. I know you're thinking that you see something common here, but we're not going to try to pull anything out of those. Remember, we just want to find out what times what will equal this. So if we pull out the x minus 3 out of both, in this case, then we are left with, if we divide that all up, hopefully you know now that we're left with this and this. Now, this is where we're going to take it one step further. So we can break this up further. And rather than trying to do it up here, which just becomes a little bit dirtier, we're going to do it here now. So out of this, we can pull out a 2x. And when we do that, if I divide this up by 2x, so we already have this factor. And we have another factor here, 2x, that's our GCF. And when we pull it out, we are left with, so 2 divided by 2, we're going to divide this up. 2 divided by 2 is, 4 divided by 2 is 2. X squared divided by x is x. Negative 2 divided by 2 is negative 1. X divided by x is nothing. Now this negative 1 here is important. I told you a couple of minutes ago that you might just say, well, these cancel each other out. They do cancel each other out and they become a 1. And up here that was fine because in this case here, 2x times 1 is just 2x. So we didn't have to change it. Here though we have, this is the whole term. So here we have a minus 2x divided by a minus 2x, and we are left with a minus 1 when we divide those up. So that has to appear. So in this case, we have fully factored this. Up until this point, it was half factored. But if you ever see that one of these factors can be further factored, then you have to do that. So going back to this question, this could not be factored anymore. This could not be factored anymore. There's nothing in common. Going back here, this cannot be factored anymore. This cannot be factored anymore. There's nothing in common. This is fully factored. This is fully factored. So in each of the previous cases I've done, everything has, each of the factors is sort of in a lowest term, so to speak. It's fully factored. There's nothing more we can pull out of it. In this case, we still could. And so we did that. We broke our second factor down even further. All right, so that's factoring by greatest common factor. It doesn't always work. So the second way I'm going to show you today is called factoring by grouping. All right. So here is a polynomial. It has 4 terms to it. We have nothing in common. G does not appear in all of these. X does not appear in all of them. 3 does not appear in all of them. Y does not appear in all of them. So we cannot factor by greatest common factor here because there is no factor in common. However, you could probably see that we do have a couple of Y's, we do have a couple of X's, we do have a couple of G's, we do have a couple of 3's. And so we can factor by grouping. So what I'm going to do here is I'm going to group these together and these together. I'm going to group these together because they have a G in common. I'm going to group these together because they have a 3 in common. Now my greatest common factor of these 2 terms is G. And so if I divide, they both have a G. So if I divide it by that, by my greatest common factor, I'm going to be left with an X plus Y. And here, the greatest common factor is my plus 3. And if I divide, so my greatest common factor of that is plus 3. If I divide it by plus 3, I'm left with an X plus Y. And now this looks like the questions that we just did. Our greatest common factor here and here is X plus Y. And if we divide this up by it, we'd be left with a G plus 3. So, nothing in common. A's not in common, B's not in common. That's a C. C's not in common, 5 is not in common, but we do have things in common. Here I have A's in common, and here I have 5's in common. So, I'm going to pull out my greatest common factor from this group, which is A. If I divide this all up by A, I'm left with a B minus C. And my greatest common factor here is 5, or plus 5, so I'm going to pull it out actually. It's, in this case, let me stop myself here. We have a 5 and a negative 5. So you know what? I know that 5 is in common. I don't know if I want a negative 5 or a plus 5. But here's the scoop. I want this factor and this factor to be the same, just like they're the same here. So if I want a B minus C, what do I have to pull out here to get it? If I pull out a plus 5, and actually let me do the, let me go the other way. Let's say I pull out a minus 5. 5 divided by minus 5 gives me a minus 5. And we have a B. Minus 5 divided by minus 5 gives me a plus 5. And I'm kind of left with a minus C here. That's, or a plus C. That's not working. Because this divided by this gives me a positive answer. And I want a minus C. So in order to get this, a minus C, that tells me that this has to be a plus 5 I pull out. If I pull out a plus 5 here, 5 divided by 5 gives me a plus B. And negative 5 divided by, negative 5C divided by a plus 5, I'd be left with a minus C, and that's what I want. So that lets me know that I'm pulling a plus 5 out and not a minus 5. And now to put this together, we have B minus C in common between these two, and A plus 5 in common as well. Let's do another example. X squared plus 4x plus 2x plus 8. 4 terms and nothing in common. With our coefficients, we have nothing in common, and we don't have x in all the terms because there's no x in our last term. So we're going to use grouping here I'm going to group these two together. What do I have in common here? I have an x in common. And so when I divide that up by x squared divided by x is x. 4x divided by, plus 4x divided by x is plus 4. All right, sorry. And what do I have in common here? I have 2 in common. And once again, I'm just going to write 2 here. I want to kind of go over this situation with you again. So if I pull out a plus 2, let's make this a plus 2. If I pull out a plus 2, I think that's my greatest common factor. 2x divided by 2 is x. And 8 divided by 2 is plus 4. If I had pulled out a minus 2, my answer here would be minus x minus 4. Now, why does this matter? If I need a minus x minus 4 to be the same as this, then I would have to pull a minus 2 out, because I need these two to be the same. So if you are ever pulling out, say, a plus 2, and you find that this and this don't match, this tells you that you should have pulled out the opposite, a minus 2. And then these two will match. You'll come across a couple questions in your homework like that, and you should be able to deal with them there, no problem. And now to finish factoring this, x plus 4 is in common, and we are left with an x plus 2. All right, one more question, and we are done. All right, and our last question here. I'm gonna do this question twice for you. So this is the same question twice. All right, so far we've been very lucky in that the first 2 terms made a pair, the second 2 terms made a pair. Made a pair, made a pair, made a pair, made a pair. That's not always the case. Plus, I know some of you may have been saying, well, I see G's in common here, and I see 3's are in common here, but what about these two have x in common, these two have y in common? Can we rearrange and make a pair? And the answer is absolutely yes. So let's go over this last question. We're going to do it twice. We're going to do it 2 different ways to show you that it doesn't matter, but it'll also show you another strategy. So here I have B in common and I have A in common. So I can factor by grouping here. I can't factor by greatest common factor because there's nothing in common in all 4 of these terms, but I can factor by grouping. And in this first group here, I have B in common. So B, and when I divide this up by B, I'm left with 3n's. And when I take minus 2 bm and I divide it up by B, I'm left with minus 2m. What do I have in common here? Between my 9 and my 6, I have 3 in common. And between AN and AM, I have A in common. So I can pull 3A out. Negative 9 divided by 3 is negative 3. A divided by A is gone, N divided by nothing is N. And I stop and I say, but it's a minus 3N, I need a plus 3N for it to match. So that tells me that my greatest common factor is not 3A, it's minus 3A. And you notice that I had waited to write in my plus or minus on this term. So now, negative 9 divided by negative 3 gives me a plus 3N, which is what I want. And 6 divided by negative 3 is negative 2. That's matching. And AM divided by A is just M left. And putting these together, 3N plus 2M is in common between the two. These are two terms, of course. And b minus 3a is in common. If for some reason you have these reversed, that's fine, because you know that 2 times 7 and 7 times 2 are the same thing. It doesn't matter multiplication the order that they're in. So if these brackets are flipped, no big deal. Looking inside the bracket, cannot be factored by anything. This cannot be factored, or there's no GCFs in those. So we've gone as far as we can. So that was factoring with b being our common factor and 3a being our common factor. Well, some of you might look at this and say, I see n's and m's. Can we do it that way? Sure. This has an n in it. This has an n in it. This has an m. This has an m. So we can rewrite this. We can put our 3b n's and our minus 9a n's beside each other. Our minus 2bm and my plus 6am beside each other. And now these have common factors, so we're going to factor by grouping. Here, between 3 and negative 9, we have a 3. And between bn and an, n is in common. So, dividing this by this, 3 divided by 3 is 1. bn divided by n, we're left with a b. And negative 9 divided by 3 is negative 3. an divided by n is an a. Perfect. And over here, 2 and 6, greatest common factor is 2. And between bm and am, we have an m in common. So this is a 2m. I'm not putting negative or positive there yet. Getting good at this. So negative 2 divided by negative 2 gives me negative 1. bm divided by m gives me a b. And we have a 1b over here, because 3 divided by 3 is 1. Negative 1 and plus 1 are not the same thing. We want this to be a plus 1 to match this plus 1. So in order to do that, my greatest common factor here must be a minus 2m. So minus 2 times minus 2 is a plus 1. All right, that's matching now. And 6 divided by negative 2 is negative 3. That's what we have over here. am divided by m, we are left with just an a. These match. That's a key. We want those to match. And so we have a b minus 3a and a 3n minus 2m. And look at that, this and this matches. So sometimes you're going to have to switch these around in order to do factor by grouping. Other times it'll just be whether the first two and the second two match up perfectly. But if you're finding that they're not matching up perfectly, this is 4 terms. Rearrange it so your like terms are beside each other, or the ones that you want to group, and start factoring. If you aren't getting the same thing inside the brackets here, it's going to be one of 2 problems. Problem number 1, you have the wrong greatest common factor. So maybe here you missed the 3 and you just divided through by n. That's going to give this the wrong number. And so that's a first mistake, wrong GCF. And the second mistake, as we've discussed here ad nauseum now, the wrong sign. So making sure you have a negative or a positive to make this match. So that is it. Ladies and gentlemen, you have begun the wonderful world of factoring. You've learned 2 ways today to find out. In this case, this times this equals this. If you want to FOIL that out, you'll get this answer. And remember, factors are just finding out what times what equals an answer. So I've shown you 2 methods of doing it. At the start of this lesson, if I said what times what equals this, I'm sure you would have thrown your hands up in the air. Now you know 2 ways, greatest common factor and factor by grouping. And If you could become proficient at those, then getting down here to the final answer is a pretty simple task. All right, that's it. Good luck with your homework. If you have any questions, reach out to me. Talk to you later. Have a great day, everybody.